Welcome to Emergency Management Associates. We're coming to you from the Area Command, 392 miles west of Kittihawk Beach, North Carolina. We want to welcome everybody to our program tonight. I'm trying to bring it up on my monitor here, trying to bring up this program on my monitor to make sure YouTube has got us live. I don't trust this venue very much, because they've let me down so many times and let all of us down so many times. And now I'm looking here, and so far I cannot see that they have me on the air live. And there we are. I'm now on the air live. Hey, Juanito, Real Beast, Demon Catman, from the east of England, welcome, welcome. Richard Smith is here. Kimball Seablay is here. Welcome, welcome, guys. We appreciate you all here. This is Emergency Management Associates, guys. For those of you that are new to this channel, this is Emergency Management Associates. We're coming to you from the Area Command, 392 miles west of Kittihawk Beach, North Carolina. Tonight, I want to talk about earthquakes. Literally earthquakes from around the world. I'm first going to take you to an earthquake that happened early Sunday morning. I want to show you this, and then we're going to talk about literally earthquakes around the world. Now, why am I showing you this? This is the Antarctic Ridge. This is the Antarctic Ridge here. Further to the west here is New Zealand here. Right smack dab in the middle of the lower Pacific Ocean, the southern Pacific Ocean, down here on the Antarctic Ridge. Sunday we had a 6.2 very strong earthquake. Again, I want to repeat the strength of the earthquakes. A 1.0 to a 1.9 are considered to be tremors. A 2.0 to a 2.9 earthquake are considered to be minor earthquakes. A 3.0 to a 3.9 are considered to be small earthquakes. A 4.0 to a 4.9 are considered to be moderate earthquakes. Moderate earthquakes that can cause moderate damage. Small earthquakes, 3.0, 3.9, don't cause much damage, but they rattle the earth underneath your feet, and they can cause consternation. They can upset people, not knowing whether the earth is going to increase in magnitude. A 5.0 to a 5.9 are considered to be large earthquakes. A 6.0 to a 6.9 are considered to be very strong earthquakes, like this one we had down here on Sunday morning. A 6.2 very strong earthquake down here on the Antarctic Ridge. Continuing, a 7.0 to a 7.9 and larger are considered to be major earthquakes. 7.0 and larger are called major earthquakes and can cause major damage. Delete Funds is asking how far from the ice cap. The ice cap is way down to the south. Okay? Way down here to the south. We're not even showing that here, but right here. This is the ice cap, several thousand miles south of the Antarctic Ridge. Now, you might think that this area would be warmer waters. Not really. This is very cold water year-round. This area of the Antarctic Ridge is very cold year-round. Over here in New Zealand, right here, this is almost always cold water down here. Up here further to the north on the South Island and the North Island, this is cooler water. It would not be wise to swim here in the open ocean. Anyway, getting back to what happened Sunday. Sunday we had a 6.2 very strong earthquake down here. I want to tell you about it. I want to tell you what happened. Okay? Everybody should know what happened. Not a lot of people know. but I'm going to tell you. Now, there are other earthquakes around the globe today we're going to talk about. But first, I want to tell you about this earthquake. Back in 1971, we had a 6.2 earthquake in the same area. Now, one of the main possible driving mechanism of plate motions is a push from the mid-ocean ridges. The mid-ocean ridges. There are several ridges in the ocean. One of them is the Antarctic Ridge. Further to the north and east, we have the West Chilean Rise and the ridge around Easter Island. And I'm going to show you an earthquake to the north of there in just a few minutes. But one of the main driving mechanisms of plate motions is a push from the mid-ocean ridges. The push of the mid-ocean ridges. Or another reason is injection of magma at the ridge crest. Injection magma at the ridge crest. Or due to hydrostatic overpressure resulting from the elevation of the ridge above the ocean basins. The ocean basins, where the ocean is. Ocean rests on flat, well, not necessarily flat, but an ocean bottom. The ocean basin, okay? If the plates are pushed apart at the ridges, an area between the two mid-ocean ridges should be under compression, right? Yes, absolutely. If the ridges are pushed apart, there is compression at the two mid-ocean ridges. On May 9th, 1971, just like this past Sunday, June 10th, an earthquake of a magnitude 6.2 hit right in the same area between the Chilean Ridge over to the east and the Pacific Antarctic Ridge. Okay, the Pacific Antarctic Ridge begins to climb to the east, to the northeast, right before it reaches South America. Right here in this same area, we had a 6.2 earthquake. Okay, back in 1971, it was followed 24 hours later by aftershocks of a magnitude 5.0. Large 5.0 earthquakes. That did not happen this time. There were no aftershocks that USGS or any of the other agencies have told us about. I still don't see any aftershocks listed on the EMSC, the European Agency site, or the USGS site. This is the difference. This is pretty much the only difference between what happened in May of 1971 and what happened on June 10th, yesterday morning. Okay? But I want to explain what happened. Delete Funds is asking, is there magma intrusion? Possibly. Possibly. Okay? There is magma down there. There is a volcano down in the Antarctic. Okay? Down deep within the ocean. Deep underneath the ocean. Near that same area, just to the north of that area, there's a deep earthen magma plume that comes from deep inside the earth. That magma plume goes up through into the crust and distributes magma all over the world, to all the volcanoes all around the world. Okay? So it is very possible, and according to scientific theory, it's possible that what happened on Sunday down there into the Antarctic could have been caused by magma intrusion at the plates. Okay? Now, I cannot get a picture or a photograph of that area at the ocean bottom. I've been laboring most of the day trying to find a picture of the ocean bottom near where this earthquake hit Sunday. I don't see, right now, I do not see any craters or any open areas where a vent that could have been where magma came up from the ocean bottom. I don't see a vent and I don't see a crater or anything down there. But it is highly possible, according to scientific theory, that magma came up and intruded at that ocean ridge, that Antarctic ridge, and near the Chilean ridge, the West Chilean Rise, they call it. Okay? An analysis of the focal mechanism, whether it was coming from the southwest to northeast, or from the southeast to the northwest. The focal mechanism. The principal shock showed the plate is at least locally under horizontal compressive stress. Horizontal compressive stress, with the maximum stress axis approximately perpendicular to the Pacific Antarctic ridge. Okay? A flat, straight axis. A flat, straight axis. That's what they believe happened. So there is a very good possibility that there was a magma intrusion and the two plates came together and caused that earthquake. Okay? I want to make that very clear. Scientists are still looking at this. They're still looking at this to determine whether it was magma or the two plates coming together causing that earthquake. The Pacific plate to the north, the Antarctic ridge, and also to the west, the West Chilean Rise. Okay? I'm going to show you that in a minute. But I wanted to put this out there. I wanted to put this out there so you could understand what actually happened. Okay? A lot of people don't understand when we have these earthquakes, and we have had quite a few earthquakes in this same area. Okay? Folks, I do not think we have anything to be worried about, but at least you'll understand what happened. At least you'll understand what happened down there in the Antarctic ridge on Sunday. And I will come back to this in just a minute and show you an earthquake to the north of there. Okay? What happened, happened. It's not the first time, and that's why I'm explaining it right now. Okay? Now, Sungazer is also talking about an X-class flare that lifted off the sun yesterday, and it's hitting Earth today. Hitting Earth today and on Tuesday, which is tomorrow. The main force of that X-class flare will be hitting the Earth tomorrow. Now, it was an X-class 1. It was an X-class 1 flare. Now, it is a very dangerous flare. Anytime we have a regular flare, a C, an M, an R, that's not as bad as an X. Those are elevated solar flares, elevated coronal mass ejections. We are fully expecting that to continue. Okay, we're fully expecting the sun to continue putting on a show for us. And we're continuing to expect X-class flares. As you know, during the past month, we've had upwards of an X12.6. Okay, that's what happened. Now, it happened on the eastern terminator. Okay, if you look at the sun, well, I hope you don't look directly at the sun, but if you were to look at the sun, on the left-hand side of it is what they call the eastern terminator, the edge of the solar disk as we see it. Okay, that X-class 12.6 launched off the terminator as we see it. It was not, I repeat, it was not a direct impact on the Earth. It was out from the sun just like this. If anything, it may have been a sideways glance blow off the Earth. which means it wasn't going to harm much of anything. Okay? I want to make that perfectly clear. The flare that launched off the sun yesterday is a little bit different, but it's not as bad as the X-Class 12.6 last month. We are continuing to monitor the sun. As I have spoken to you before, I monitor the sun for Mark Wages, which is Wages World on YouTube. Wages World here on YouTube. I monitor the sun. Mark Wages sends me notes and notifications when he's going to go on the air. And I monitored a members only chat yesterday, and immediately after the members only chat, he went live for everybody. Now, folks, Mark Wages is a good man. He knows a lot. He studied. If you want to know the truth about any solar flares, I would highly recommend you go to Wages World after this program is over and check it out. Okay? You will get a lot out of it, I promise you. Now, someone just had a question here. I'm going to go back here to try to find it. Heather, I've not heard from Don all day. Heather is asking if Don has been here. I haven't seen him all day. I kind of wondered if he's okay myself. Sungazer said she felt dizzy today from that X-Class flare. Yes, it does do that to people. Flares can have effect on human beings and all animals. And I'm talking all animals. It doesn't matter whether a human being, a dog, a horse, any other kind of mammal. Solar flares can have an effect on everything and everyone. Okay, I want to make that perfectly clear too. Oh, Delete Funds is the one that asked the question. Any new activity in Iceland? Folks, we do not have any more information on any fissures or volcanic eruptions in Iceland as of yet. It is going to happen. I can promise you there will be another eruption over in Iceland. It just has not happened yet. The people in Iceland are still working to protect the power plant and the Blue Lagoon and down to the southeast over at Grindavik. They're still making sure that they're raising the defense wall around Grindavik and also around the power plant and just next to it to the west, the Blue Lagoon Spa. Okay? They're fortifying those walls, and rightly so. Because the last eruption over on Iceland from a huge fissure that opened up that was 3.4 miles long, that's pretty long. I'm sorry, not miles, 3.4 kilometers long, was huge. And yes, the eruption only lasted 8 days compared to a year prior where the fissure, actually no, I'm sorry, that's another volcano entirely. But that magma eruption that happened in Iceland did not last as long as the previous eruptions. Okay? But something else you need to know about that magma eruption is that lava eruption over in Iceland. Folks, one of the reasons that erupted was because of the Mid-Atlantic Ridge expansion. The expansion of the Mid-Atlantic Ridge. Okay? We've talked a lot about that, and I'm going to continue to talk about that. One of the biggest reasons that those eruptions are happening in Iceland is because of the expansion of the Mid-Atlantic Ridge. It's forcing more and more lava into those areas. The expansion of the ridge is causing more and more lava into the area around Iceland. And we're going to continue to have volcanic eruptions in Iceland. Okay? I can promise you that's going to continue. Now, I'm going to talk to Professor Thorvaldsson over in Iceland probably tomorrow. So I hope to have more of an idea what's going on after I speak to him tomorrow. But right now we do not have any volcanic eruption to speak of in Iceland, and that's a good thing. The lava in the lava fields, though, as you can recall, we had a lot of lava that pushed out of the last eruption. That lava is still degassing. That hot, very hot lava is degassing, still throwing up some SO2, sulfur dioxide, and carbon dioxide. Now, depending on where the wind is blowing, it can blow those chemicals, those aerosol chemicals, throughout the area, depending on where the wind is blowing. And they still can become somewhat toxic in large concentrations. The Icelandic authorities are also monitoring that. Okay? They're also monitoring the earthquakes that are still happening over on Iceland. Neither USGS or the European agency are reporting earthquakes. In order to get any information about the earthquakes in Iceland, you have to go over to the Icelandic Met Office to pull any information. And yes, they have had some minor earthquakes and tremors. Those are continuing. I think the strongest earthquake they had was just a few days ago. It was a 3.1 magnitude earthquake, a small earthquake. Okay? Just a small earthquake. Richard Smith says he strongly hope not, but feeling there are going to be some major landslips and slide going to happen soon. It's true. Okay? Even over in Canada and the east coast of the United States, we're still going to have landslides and we're still going to have earthquakes. And I'm going to show you an earthquake over in Georgia today. Over in southern Georgia today. We talked about 2 earthquakes on Friday over in Georgia, and Georgia just had another one today. Okay? That's because of the mid-Atlantic plate expanding, pushing the North American plate. The United States, Canada, and Mexico in a southwesterly direction, and Europe and Africa in an eastward direction. It's happening. It's going to continue to happen. Do you guys have any more questions for me as of yet? I'm going to continue my explanation of what's going on here. Okay? All right. Let's continue this. Now, I'm taking you back here. I'm sorry, stupid computer. I'm taking you back here to the USGS map. I just got through explaining that we had a 6.2 earthquake right down here on Sunday. Now, NCWQ Disaster News and Explorer covered that earthquake. She used Earthquake 3D and showed the earthquake there. I just got through explaining it. Now, as I said, the Antarctic Ridge goes up to the northeast here. It meets up with the West Chile Rise here. This is the other Southern Pacific Ridge here, the East Chile Rise right here. Or excuse me, the West Chile Rise right here. Also, what you need to know is right in this same area we have Easter Island. Easter Island. We have had earthquakes here. Now, this earthquake right here, it just happened just a short time ago. This is over on the East Pacific Rise. The East Pacific Rise. This is a large 5.1 earthquake. This happened at 6:34 p.m. Eastern Time this evening. This just happened before we came on the air. A 5.1 large earthquake here. Notice where it came from. The southern Antarctic ridge comes from way down here in the southern Pacific, and it goes up here. Now, it's very possible that this 5.1 could be, and I'm saying could be, an aftershock of that 6.2 the other day. Notice that the Antarctic ridge comes up here, and this turns into the Central East Pacific Rise right here. A 5.1 earthquake here today. Now, I want to go over here to the west. Okay? This earthquake is is not in, but near Luvuka, Fiji. 189 kilometers east-northeast of Luvuka, Fiji here. Okay? You can see where I'm talking about right here. 189 kilometers east-northeast of Luvuka, Fiji. This is a 4.2 magnitude earthquake. This is also 537 kilometers deep. 537 kilometers deep. Now look at the depth to magnitude conversion chart. Okay, we go up here to 535 kilometers deep. Here is 540 kilometers deep. In order to ascertain exactly what's going to happen here, as you know, these deep earthquakes propagate stronger, more shallow quakes. This earthquake that we just got through having today near Luvuka, Fiji, is 537 kilometers deep. We have to add at least a 1.07 to that earthquake. Okay, it's a 4.2 earthquake. We add another at least 1.07 or 1.08. What does this mean? What this means, folks, is that this 4.2 earthquake near Luvuka, Fiji, is going to propagate a larger, more shallow quake. Sometime within the next 72 hours to 10 days, 3 to 10 days, we're going to have a larger 5.2 to 5.3 earthquake. A 5.2 to 5.3 large earthquake down there in the Pacific Ocean. It could happen that that earthquake will come over here to Tonga or out here to Samoa, or it could stay here in the Fiji area, or it could go over here to Vanuatu here, or it could go over here. Look at this. This is Solo Vanuatu here. This is a 5.3, only 128 kilometers deep. So this new earthquake that we're talking about, at least a 5.2 to 5.3 earthquake, is going to come over here to Vanuatu. It could come further west over here to the Solomon Islands, or even over here into Papua New Guinea. Papua New Guinea. Today here in Papua New Guinea, we had a 4.6 earthquake. This is 54 kilometers deep. Still a very shallow earthquake. I want to enlarge this map to show you where it happened. Okay? I want to make very clear what happened here. Again, this is in the mountainous regions of Papua New Guinea. There are population enclaves here. There are population enclaves of small villages all throughout Papua New Guinea. There's a village over here to the northwest. There's another village over here to the northeast, and more smaller villages further over here to the west. This is a 4.6 moderate earthquake. The earth still shook here. The earth still shook here. Okay? Possibly doing moderate damage. These poor people that live in this area, folks, don't have much. Their homes are not made as sturdy as ours. Many of these people live in wooden or cardboard shacks. When the earth shakes, even with a moderate earthquake, people can get scared, and rightfully so. But again, we can see a large earthquake coming over here to Papua New Guinea sometime within the next 72 hours to 10 days. It could also reach further over here to the west. It could reach over here where you see my cursor here. This is Papua, Indonesia. It could reach all the way over here into Indonesia. Over here, this is in south central Indonesia. This is a 4.5 moderate earthquake here. It's out in the Molucca Sea here. Okay, a 4.5 moderate earthquake here near Tuwal, Indonesia. We've had many earthquakes here. This is 64 kilometers deep. Now I want to go over here to show you another earthquake that hit here. Okay, this earthquake hit here near Ambon, Indonesia. Ambon, Indonesia. This is a 4.7 magnitude earthquake. A 4.7 magnitude earthquake. Still a moderate earthquake over here. This hit again on the island here. This is a tropical island basically. Okay? Very high in foliage. This is in the lower part of the mountain range, the foothills of this mountain range here. Yes, there are villages here to the northeast here. Villages all over this area. Anytime you see a body of water like this, a harbor type area, there are people that live here and fish here. Okay? This is a 4.7 moderate earthquake here. Okay? Why do we have earthquakes here? It's put simply like this. This whole area here, including over here in Myanmar, used to be called Burma here. We see my cursor here. Myanmar, Cambodia, Thailand, down here to the South Vietnam, all the way down here into Indonesia, Australia, all the way over here to New Zealand, and over here into the southern islands of Samoa and Tonga. This is a huge subduction zone. This is the world's largest subduction zone, meaning there are 7 different plates here, 7 different tectonic plates here. Each one of them are subducting or going under the other. Each and every plate here is going up under the other. That is what is causing all these earthquakes. One plate going up underneath the other. Over here in Sumatra, northern Sumatra, this is a 4.4 magnitude earthquake here. Why did it happen? Again, the edge of the plate is right here. The edge of the plate is right here. A 4.4 magnitude earthquake, 179 kilometers deep. Still a fairly shallow earthquake. A fairly shallow earthquake. Sam is here from New Zealand. Welcome, Sam. We appreciate you here. I want to go back and talk to you about the earthquakes that are happening in New Zealand today. Because, as you see, the USGS is not showing any earthquakes here in New Zealand. And yet New Zealand has been having minor earthquakes, small earthquakes, and even moderate earthquakes. 4.0 to 4.5 earthquakes here in New Zealand. The earth is shaking. The earth is shaking here. The other earthquake that happened over here, still in the northeastern Indian Ocean here, is in the Nicobar Islands here, between Sumatra and India. This also is a 4.7 moderate earthquake out here in the open Indian Ocean here, not far from the Nicobar Islands here. Let me zoom in here and I'll try to show you some of the Nicobar Islands here, right here. These islands here that you see are what they call the Nicobar Islands. They're mostly uninhabited except by passing sailboats and other boats that come here to visit. They're mostly uninhabited islands. A friend of mine visited here with his wife, and they had a lot of fun over here in the Indian Ocean. Now, one other earthquake that happened today, over here in the mid-Indian Ocean. Folks, this was another large earthquake, a 5.0 earthquake here in the Indian Ocean. This is out in the middle, okay? Out in the middle of the Indian Ocean. This is near the islands of Mauritius, Mauritus, Port Mathurin, Mauritius Islands, 208 kilometers east-northeast of Port Mathurin, Mauritius Islands here. Let me zoom in here so you see it. Okay? This is where Port Mathurin, Mauritius Island is here, out in the middle of the Indian Ocean. This is where the earthquake is. Now, folks, look where it's at. Look where it's at. Why did it happen? Because it's on the fault zone here. It's on the mid-Indian fault zone. Now, there's another fault zone here to the north. Look at this. This is called the Owens Fracture Zone. This area to the north is called the Owens Fracture Zone. It's a big deal. When we get earthquakes here, those earthquakes travel to the north. And they travel up here. Those earthquakes end up here in Saudi Arabia, Iraq, or Iran. Okay? If it comes up this way, these earthquakes will be hitting here within the next 72 hours to maybe 5 days. 3 to 5 days. Notice further up here. Okay? As you can see these earthquakes here, I talked about these earthquakes over here in the Nicobar Islands and northern Sumatra. All that energy comes from over here in southern Indonesia. And it also ultimately comes from over here in the Tonga, Samoa, and Fiji Islands here. All earthquakes originate from this area. Now, look where this earthquake fault here comes from Sumatra over here through the Nicobar Islands and over here into northeastern India, Burma, Myanmar area here. Then it comes here through the Himalaya Mountains, the edge of the plate here. Next we have over here a 4.3 earthquake in Afghanistan. A 4.3 earthquake here in Afghanistan. This is 186 kilometers deep. Still a fairly shallow quake. Just to the northwest here, this is a 4.5 in Uzbekistan. A 4.5 magnitude earthquake here, a modern earthquake over here in Uzbekistan. To the northeast here in China. Again, KUQA China, Kuka China. We've had earthquakes here all last week. They've been happening for about 6 months now. This is a 4.6 earthquake here, 12.5 kilometers deep. Up here you see the edge of one of the plates here. This is an earthquake fault in China. That's why this earthquake hit here. Okay? But note, look what USGS is not telling us about. I want to make this perfectly clear too. Right here, I'm going to zoom into the Turkey-Syria border area here. There are 48 earthquakes right here. 48 earthquakes in this area. Why? As I've explained before, the reason we're having so many earthquakes here is because a year and a half ago, January 2023, we had a 9.0, 10.0 earthquake here. It killed over 5,000 people and left over 5,000 people injured. These people are still recovering from the earthquake, both in Syria and eastern Turkey. Every time we have an earthquake here, people start panicking. No matter how small the earthquake is, the people panic. Most of the earthquakes here were 2.5, 1.0, 1.5, and upwards of a 3.0 earthquake. So anywhere from a tremor 1.05 all the way up to 2.5 minor quake, all the way up to 3.5 small earthquakes. 48 earthquakes here in this area today. 48 earthquakes here. Why is USGS not talking about them? Inquiring minds want to know. Over here in northern Turkey, there are about 15 earthquakes here. More earthquakes in central Turkey and southern Turkey here. Why are they not talking about it? There's probably 18 earthquakes here in western Turkey. There's another 7 earthquakes here in the islands just west of Turkey. The islands west of Turkey belong to Greece. These are called the Dokanese Islands here. The Dokanese Islands. The earthquakes here are 2.5, 2.7, 1.8, 1.9 type of quakes. The 1-pointers are tremors. The 2.5, 2.7, 2.8 earthquakes are minor earthquakes here. These in the Dokanese Islands here. Down here is Crete, Greece. We've had 2 earthquakes here near Crete, Greece. We have 25 earthquakes here in Greece itself, mainland Greece. Over 24 earthquakes here in mainland Greece. And more earthquakes up here in Albania. Herzegovina. Bosnia-Herzegovina right here. 2.7 earthquakes here. Over here in Croatia, 2.5, 2.7, and 2.8 earthquakes here. Why are they not talking about them? Down here in Sicily, 2 small earthquakes down here in Sicily, and that's not all, folks, there's more. Stromboli volcano and Mount Etna volcano are also here, and both of those volcanoes are active. More earthquakes over here in the shoe of the boot here. The boot is called Italy. Down here in the shoe of the boot, we have several earthquakes here. More earthquakes up here to the south of Italy. We have 25 earthquakes over here in central Italy. I've gone through and counted them. USGS is not showing them at all. Why not? We have 2 minor earthquakes over here in northeastern Italy. Over here in northwestern Italy. Over here in the resort area of Italy. We have 3 minor tremors and minor earthquakes here. Over here in the Alps. The Italian Alps, the Swiss Alps here, Germany, and over here in France. Some minor earthquakes here. Only minor earthquakes here in the Alps of Switzerland, Germany, and France. We have a couple other earthquakes over here in central France. Over here to the north of France. Normandy in this area here, we still are having some minor tremors here. We've had minor earthquakes and small earthquakes up here near Normandy, France. Okay? Down here, this is the border area of France and Spain. There are 2 minor earthquakes down here. There are several other small earthquakes and minor earthquakes down here in the southern Spain area. Nothing big, just minor earthquakes. Down here, this is the Western Mediterranean. This same earthquake fault. We talked about this before. This same earthquake fault goes out here into the Mediterranean. We have 3 earthquakes here. 3 earthquakes here. The same earthquake fault goes out over here through the Strait of Gibraltar. We have a couple earthquakes here and a couple more over here in Portugal. South of Portugal, over here in the Azore Islands, we have a couple more earthquakes. Okay? Then I want to jump down here into the Canary Islands. Down here, just off the coast of one, I don't remember the name of this island here, but just off the coast to the northwest here, we have another 2.5 earthquake here. We have another earthquake over here, we have another earthquake over here in the Canary Islands here. Nothing big to worry about, just a tremor here. Just a tremor here. Now, one other island here I want to point out. This is La Palma Island. We keep having minor tremors and minor earthquakes over here on La Palma Island. Right here, this is the largest volcano over on La Palma Island. This volcano here made La Palma Island. The end of last year, we had a volcano that was erupting right here. It was erupted right here. When it first started erupting, everybody thought it was a main volcano. It wasn't. Again, a fissure opened up, just like we have had in Iceland and over in Hawaii. A fissure opened up. As the fissure started closing down, we had several craters left, and the craters kept erupting lava out of them. Major eruption at this volcano. And it erupted for nearly a year. Not quite, but nearly a year. I think 7 or 8 months. Okay? It has not been erupting ever since. But we have had earthquakes along the southern spine of La Palma Island and over here near what they call Los Llanos. Los Llanos is a town along the western coast of La Palma Island. We have had earthquakes here in this area here. Okay? We've also had earthquakes over in the western Azores. Now I'm going to zoom out here and show you that. Out here just west of the Mid-Atlantic Ridge, we have a group of islands here. These are the western Azore Islands. We have had earthquakes right here. We've had earthquakes over here on this long, narrow slit of an island here. A lot of earthquakes. And in fact, last year they had evacuated this island here. It has 3 volcanoes on it. They evacuated this island here because there were so many earthquakes here that they thought that each and every one of these volcanoes was going to erupt. So they completely evacuated this island here. But they have let these people back. Yet they're still having earthquakes here. Not as many, but it's still they're having 1 or 2 earthquakes here a day. Minor tremors for the most part. 1.0 to 1.9 tremors, and occasionally a 2.5 to 2.6 earthquake here. Okay? Again, we're going to continue to see large earthquakes originating from down here in the South Sandwich Islands over here, or over here like we had on Friday, and that came up the Mid-Atlantic Fault here. Those large earthquakes came up the Mid-Atlantic Fault, and they continue to travel all the way up here towards Iceland and further north. On Saturday and again yesterday, over here near what they call Svalbard. Svalbard is a small, minor group of islands here that belongs to Norway. Over here near Svalbard, we had a 4.5 earthquake here yesterday. That is going to continue. We've seen 4.5 earthquakes here, and even further north up here near the North Pole. Those earthquakes are going to continue. Again, the Mid-Atlantic Fault is expanding. Okay? Does anyone have any questions for me so far? Does anybody have any questions for me so far? Now, before I leave the northern part of Europe here, over here in Scandinavia, we have had some minor earthquakes down here in the south part of Norway, and also down here in southern Sweden. Now, over here in southern Sweden, right here where my cursor is, this is Dalarna. This is Dalarna, folks. Dalarna, Sweden. Boy, I can't stop speaking Swedish. I can't stop speaking Swedish. Excuse me, I'm sorry. Dalarna, Sweden. Now, when you get me speaking Swedish, I can't stop. Okay? Now, I want to show you what is famous over in Dalarna. Excuse me. I want to show you what is famous over in Dalarna. Okay? Dalarna, Sweden. Okay, this is what it looks like. I've actually been here to Dalarna. There are a bunch of lakes. Some of those lakes are like fjords. Over here in Sweden during the wintertime, they do a lot of skiing. During the spring and the summer, they do a lot of hiking. It's a very beautiful area. But one of the other things that they do is they make horses. Miniature wooden horses. Miniature wooden horses. I want to show you one of these horses. These are hand-painted horses. These are hand-painted horses. Yes, some of the horses are 100, 200 feet high. But they also make small handheld horses. They're called Dalarna horses. Dalarna Hästar in Swedish. Dalarna Hästar. This is a Dalarna Hästar here. Hand-painted horses, wooden horses. You can get small horses that are maybe 2 or 3 inches in height. You can get larger ones that are 6 to 8 inches, 10 inches, and even 2 feet high for your home. Out in your yard or your home. They're absolutely gorgeous, as you can see. I've been meaning to show you this for quite some time. Every time I mention Dalarna horses, I want to show you this. These are cool. This is the world's largest, what they call Derklarian horses. Okay? Made of concrete, located in Avesta, Sweden. This one's made of concrete here. But they're all hand painted in the same manner. It is really cool. Laura Marie's here. Thank you for being here, Laura. We appreciate you being here. Does anybody have any questions so far about anything I've talked about? I cannot play music here on this channel. They will take me off, or they will give me a slap on the wrist, which could mean 24 hours on the beach. I don't play music on this channel. I'm glad you subbed on this channel, but we don't play music here. Hurricane Heather says, those horses are so groovy. Yes, they are. They are really cool. They are really cool, guys. Like I said, I've been meaning to show you this every time I've talked about earthquakes here in Dalarna, Sweden. They are absolutely gorgeous. They're absolutely gorgeous here. Again, those horses are made right here where you see my cursor. Dalarna, Sweden. Okay? Okay, Hurricane Heather is asking a good question. Okay, during the past while, we've had a lot of earthquakes around Mount Shasta and Mount Lassen. Okay, this is over here in northern California. Okay, over here in Northern California, we've had some good-sized earthquakes. Yesterday, Heather asked to check out the earthquakes over near Mount Lassen and Mount Shasta. Okay? The earthquakes at Mount Lassen yesterday, I haven't had a chance to check on them today, but the earthquakes that are hitting Mount Shasta and Mount Lassen are 2.0 to 3.0 small earthquakes. 2.0 minor earthquakes all the way up to 3.0 earthquakes at Mount Shasta and Mount Lassen. Now, as I showed Heather yesterday, we have had earthquakes there. Those earthquakes are continuing. Those earthquakes are continuing. Let me pull up the Lassen Volcanic Observatory. Lassen Volcanic Center. I want to show you what we have here in the way of earthquakes. Okay, this is one. There are anywhere from 6 to 10 seismographs all over each of these volcanoes, both Lassen and Mount Shasta. This is LRD, which is the seismograph that you see here. The seismogram here, printed out by the LRD seismograph, is not showing anything. It's worthless. Okay? Further over here to the central west side of the volcano, this is also worthless. Okay? Not showing anything. I'm coming over here to the southwest side of Lassen here. This does not show anything at all. Right here. I shouldn't say anything at all. Let me go here. I want to show you this. We're seeing minor tremors here. Last night, the seismograph started recording information at 5:30 p.m. last night. All we're seeing here are minor tremors here. All we're seeing is minor tremors. The red line right here, this is a steam signal here. This is a steam signal. This is a steam signal here. The thicker the lines here, folks, the thicker the lines show the magma coming into the volcano. The magma is coming in to the volcano under pressure. And as a result of it coming in under pressure, we see these tremors here. Each of these vertical lines are tremors here. These are all tremors. If the vertical line does not have a center to it, this is a steam signal. A steam signal. This red line here is a computer-generated line. It's also a steam signal. Mount Lassen is throwing steam. Throwing steam. Look at this thick line right here. This is 12:30 over here on the left-hand side. 12:30 a.m. this morning on this left-hand side. Look how thick of a line this is. This is a lot of magma coming into Mount Lassen. A lot of magma. Over here, on the left-hand side, this would be 2:30 this morning. Again, we're seeing tremors all the way through here. But over here, this is 2:44 a.m. this morning. 2:44 a.m. Look at these earthquakes here. Look at these earthquakes. This red line does not have to have a middle dot in it. Again, the red is computer generated. You see the blue dark line here. This is an earthquake. Okay, this is like a 3.0 earthquake here. This is at least a 3.0, maybe even a 3.3 earthquake. However, let's look at the second earthquake here. This is different. This is like a 3.5 earthquake. This is at least a 3.5 earthquake right here. Okay? This again is 2:44 a.m. this morning. Okay? 3.0 and then maybe a 3.5 earthquake. Okay? After that, we come over here to 3 a.m. We're still seeing good-sized earthquakes. This is at least a 2.8, 2.9 earthquake over here. 3 a.m. this morning. And you can see here at about 3:07 a.m. this morning, or not 3:07, 3:02 a.m. this morning, we have a 2.2, 2.3 earthquake right here. We have a bunch of other tremors here as well. Okay? Mount Lassen is busy. It's very busy. Down here to the right, this would be 7:14 a.m. this morning. This is a 2.7, 2.8 earthquake here, and a 2.5 earthquake here. Again, you see these thicker lines. The thicker lines are indicative of more and more lava coming into the volcano. And you can see what happens. The lava coming in under pressure in the volcanic chamber fractures the rock, causing earth movement, earthquakes. Earthquakes. Let's continue scrolling down here. Here, again, fracturing earthquakes. We're seeing tremors here. Down here, we're seeing rat-a-tat-tat. They're trying to go here near the volcano to the upper magma chambers to pull steam out of Mount Lassen. That's why you see this rat-a-tat-tat. These red lines here are steam signals. They're computer-generated steam signals here. Mount Lassen is steaming. Now, Hurricane Heather's here in the chat, and she told me this last night as well. They're seeing ashy-looking steam coming from the volcano. Ashy-looking steam is ash in the air. The holes in the upper part of the summit of the volcano the holes are just not small enough to just have steam coming from, but now the holes are large enough where it's pushing ash out of the volcano. It's pushing ash from the volcano. Now I want to take this seismogram down, and I want to show you what exactly is going on here at Mount Lassen. Let's scroll down here. Lassen Volcanic Center has experienced hundreds of eruptions scattered over 500 square kilometers, 200 square miles during the last 825 years. Hundreds of eruptions over 825 years. The most recent 3 notable eruptions were Chaos Crags 1,100 years ago, the Cinder Cone 1666 AD, and Lassen Peak. Lassen Peak erupted in 1914 to 1917, 3 years of eruptions. What is that telling us? Right now, it's been over 100 years since the last eruption. And you see what I just got through showing you. We just saw an entire seismogram full of activity, from tremors on up to small earthquakes. And Heather and her neighbors are seeing gray steam coming from the volcano. Ashy looking steam, which means ash is being pushed out of the volcanic crater. Pushed out from the volcanic crater. Now I'm going to come back here to this map in just a few minutes. I want to show you what is going on here. I want to show you what's going on here. That's Lassen. This is Mount Shasta. Okay? I want to show you this. This is seismograph LGY. Seismograph LGY. All it's showing here is magma coming out of the volcano. Or not coming out of the volcano, coming into the volcano. The thicker the lines, the more magma that's coming into the volcano. And as we get thinner lines, that happens. It's called magma pulse signals. Magma pulse signals. The more magma we have a thicker line, and then it goes thinner, which is less magma, and then the less magma signals turn into thicker magma signals like you see down here. Okay? It's called magma pulse signals. Here you're seeing some tremors here. We're seeing a 2.5 earthquake right here. Okay? Right here, this red signal over here on the left-hand side, that's a steam signal. Mount Shasta is also steaming. But you're seeing these thicker lines here, and we're hardly seeing any earthquakes or tremors. That's not good. That means that USGS is not showing us everything going on. They either don't show us what's actually happening, or they doctor the seismogram like this. This seismogram has been totally doctored here. They play with it. It's called abstract. They don't want us to see exactly what's going on here. Let's go over to this one here. This is seismograph LMC. LMC. We scroll down this seismograph here, and we see some tremors here. But that's all we're seeing. We see bits of magma coming into the volcanic chamber, and because of that, we're seeing some tremors here as this magma comes in, fracturing the rock here. It's fracturing rock all over here. But they're still not showing us everything. Okay, let's come over here. This is LDL. Here on LDL, we see pretty much the same thing. We see a few tremors here. Here we see a lot of magma here, and then it disappears. Less and less magma. But again, they're not showing us everything. This seismogram has been doctored as well. It's been doctored. They mess with it. Let's go up here to the north, or the western side of Mount Shasta. This is seismograph LCSB. This has been doctored. This whole seismograph is nothing but what they call abstract, meaning they mess with it. They mess with it. We go up here. This is seismometer LAMB. It doesn't show anything. They've taken this seismograph down. Okay, let's go over to LBO. They've taken this offline as well, not showing us anything. We come over here to LMP. This has also been doctored here. They're not showing us anything here. I come down over here to the far south right side of this seismogram here, or the mountain here. Look at this. LTI here has been doctored here. It's all false information. I come down here to furthest to the south. This is LSR. They've taken this seismograph down. This is LBK. They've taken this one down as well. So there's really only one seismograph here that's even putting out any kind of information. I'm sorry, this is not that's not LBO. Now I'm trying to find the one that they had here. LPK they've taken down. Was it LCSB? No, they messed with that. Come on, which one was it that they had left up here? LDL? Yes, LDL. This is the only one that's showing anything here at Shasta. the only one. They're playing with us. They don't want us to see what's going on here at these mountains. They don't want us to see. Okay? Look at that. This little bit of magma coming in here, they don't have anything but very tiny tremors here. They have some tremors here, a tremor here, further off to the side here at 10:15 a.m., tiny tremors. Over here this afternoon, just after 2:45, near 3 p.m. here, we have some tremors. They're not showing everything going on. The most magma is up here yesterday evening, last night. This doesn't happen that way. If they have magma here, it just doesn't stop. And that's pretty much what they're showing here. It stopped. They're playing with us. They don't want us to see exactly what's going on. But if Heather says there is gray steam coming from the volcano, now I'm going to go back here and I want to show you what's going on. When the volcanoes get to the point where they're going to start erupting, before they start erupting, they're emitting steam, aren't they? 6 to 7% of magma is water. 6 to 7% of all magma is water. When the magma is hitting that huge volcanic rock that's a plug of the volcano, magma's hitting that plug and that plug starts to come apart. It fractures it. That plug fractures. Tiny cracks appear in the plug. When that magma continues to hammer away at that plug, steam starts coming from the magma. The water is being released from the magma in terms of steam. Steam starts coming through the plug like this. As that hot steam comes through the plug, the tiny fractures in that rock plug become larger. It's a scientific lesson here. It's a physics lesson. Hot steam causes larger holes to develop in that lava plug. The lava plug was left there from the last time these volcanoes erupted. The volcanoes are emitting steam. In this case, ash. Ash, meaning those small fractures in that magma, that lava plug, have got larger. The holes have gotten larger. And that plug is emitting ash. Ash is a byproduct of magma, isn't it? Ash is a byproduct of magma. Ash is coming out of those holes with the steam. That's what's happening. That's what happens. Richard Smith says it looks like bubbling coming out of the one near me, Ron. I can see on Google Maps. Yes, it does. That happens, Richard. It absolutely does. One year's Ras says working near Wilhoit today, he says, I noticed there's a little bit of tremor activity from rocks that were on the side of the road. Yeah, that happens too. It very much happens. Now, do you guys have any questions? I know I've taken a lot of time showing you what's going on. But the reason I've taken my time showing you what's going on, I wanted to show you what's happening. Okay? You deserve to know what's happening. Yes, those volcanoes are beginning to the point of erupting again. The Mount Lassen looks like it's going to erupt sooner than Mount Shasta. Okay? It last erupted in 1917. 1915 and 1917. Okay? So now we've seen another 7 years go by. 170 years since the last eruption. it might be getting ready to go again. We don't know how bad or how strong the eruption is going to be, but it looks like it's getting ready. Okay? Mount Shasta and Mount Lassen are the southern part of the Cascade Mountain volcanoes. They're the southern part of the Cascade Mountain volcanoes that goes all the way north to just north of the Canadian border. Okay? Every volcano from just north of the Canadian border all the way south to Mount Lassen and Mount Shasta are part of the Cascade Mountain volcanoes. And each and every one of those volcanoes is moving. There is movement at every one of the volcanoes. We've talked about it in the past. Kristen Cash will say, would Lassen then affect Cascadia? Possibly. Possibly. Why do I say that? Folks, wherever there is subduction, there are going to be volcanoes. You cannot have volcanoes without subduction. You cannot have volcanoes without subduction. Okay? There's always going to be volcanoes. And we know darn well that the Cascadia megathrust earthquake is right along the Cascade Mountains. Okay? Let me turn over here to the USGS map again. Okay? I want to show you this. This earthquake fault here. This earthquake fault here is the Cascadia subduction zone. This inner side of the Cascadia subduction zone runs alongside the coastline of British Columbia, Canada, Washington, Oregon, and all the way down here to Northern California. The Cascadia subduction zone. There are ancillary faults coming off the Cascadia subduction zone. Now, let's go back north. I want to show you another another earthquake fault. This same earthquake fault right next to Queen Charlotte Island here, this is the Juan de Fuca fault. You can tell the Juan de Fuca fault because it looks like a zigzag pattern. This is the Juan de Fuca fault. It is being said by the seismologists. All the scientists believe that the Cascadia the Cascadia subduction zone earthquake will happen right in this area here, either along the Cascadia subduction zone or the Juan de Fuca fault area. It will happen right here. I've explained what's going on. That earthquake will be so powerful, a 9.0, 10.0 earthquake, just like we had in the Turkey-Syria border region a year and a half ago. It's going to cause massive destruction. The earthquake fault is going to shake this whole area from Alaska. The earthquake fault is going to shake from here all the way up here to north into Alaska. It's going to shake Alaska up here, all over this area. It looks like we've had another earthquake here. Folks, this is near False Pass, Alaska. False Pass, Alaska. Folks, this is a good-sized earthquake. This is a 4.5 earthquake up here at False Pass, Alaska. It's along the ocean, the Atlantic, excuse me. This is the Aleutian Island Fault Zone. It could come up here. It could come up here into the Gulf of Alaska. And it could come back down here through either the Cascadia subduction zone or the Juan de Fuca fault. We've seen earthquakes here on the Juan de Fuca fault before. Now, the Cascadia megathrust earthquake is going to be felt all the way up into Alaska. That's also going to be felt here in the Washington, Oregon area. But it's also, regardless of where it is, it's also going to be felt down here, Northern California. I want to show you something else. Right here. This is a 2.3 earthquake. This is just west of the Triple Junction area. The Triple Junction area is right here. The Cascadia subduction zone here. The Gorda Escarpment running further out into the Pacific here. And the San Andreas Fault here. The junction of the San Andreas, the Gorda Escarpment, and the Cascadia subduction zone is right here. It's called the Triple Junction. Out to the east from here. East of this area is called the Mendocino Fault Zone. The Mendocino Fault Zone. Right up here, this is a 2.3 earthquake. Further south here, also near Petrolia, is a 2.0. 2.0 earthquake. Out here is the Mendocino Fault Zone. Up here to the northeast, this is Willow, California. Also a 2.0 earthquake here. Okay? It happens, guys. And it's going to continue to happen. It's going to continue to happen. And folks, it'll probably continue to happen until we get a Cascadia megathrust earthquake. It's going to continue to happen until we get that Cascadia megathrust earthquake. Promise. Promise, guys. It's going to happen. Now, let's go back north here. It's Monday evening. Usually on Mondays, we talk about what is happening here in the Cascadia subduction zone. That's what we're going to right now. Over here, just north of Mount Rainier, this is Carbonado. This is a 1.5 tremor here at Carbonado. Carbonado also has a seismograph here. It has a seismograph here. Let's go over to the Pacific Northwest Seismic Network. Over here we click on seismographs. We see map. So we click on the seismograph map. Okay. Search for station. Let's type here CARB. 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 For Carbonado. We click on the CARB, CARB. We come over here to view seismograph. This is the Carbonado repeater. Okay? This is presently what we're looking at here at Carbonado. These are earthquakes happening here just northwest of Mount Rainier. This is happening right now. Tomorrow, they're not going to show this to us. I will try to get here tomorrow and show you what the seismogram looks like, but they're not going to show us this tomorrow. They alter it. They change it. So let's go to the previous seismogram from today. Look at this. All this zigzag that you see here is false information. All the zigzag here is false information. It's called abstract. Abstract. Each and every line here should be a solid line. Each and every line here is 15 minutes long. It should be a solid line, not zigzag. This is false information or abstract. What they're showing here at Carbonado here is a 3.0 earthquake. It's got a dot in the middle of it. This is a 3.0 earthquake. This happened about 4:10 a.m. this morning. Okay? Early this morning. Nothing else is being shown here. They have doctored this seismogram. They have doctored this seismogram. Now, if you want to, we come up here to the left-hand side, just above the seismogram. It says BHZ here. This is the main seismogram that they're going to show everybody here. You see this down signal here? We have two other seismograms to take a look at. Let's click on BHE. It'll show us another seismogram. Hopefully this new seismogram will not be doctored. Sometimes we can come up with another seismogram that's going to show us additional information. This does not show us much of anything. I believe this is showing us some VLF wave lines. Yes, VLF waves are caused by incoming magma into the volcano. In this case, Mount Rainier. Let's go up and pull the other seismogram here. This seismogram here is BHN. The BHN seismogram should be showing us the VLF waves. VLF waves caused by magma coming into the volcano. If it hasn't been doctored. Yes, they're still showing some VLF waves. Look at the VLF waves here. Okay? They're showing us some VLF waves, and they're still showing the 3.0 earthquake here at Carbonado. It was not just a minor tremor. It wasn't a 2.0 earthquake, as they had shown us. This is definitely a 3.0 earthquake. If it was a 2.0, it would be much shorter. This is a very long line here. This is at least a 3.0 earthquake here at Carbonado. Now I'm going to pull up another seismogram here. The next seismogram I'm going to pull up is hopefully RER, Emerald Ridge, Mount Rainier. Okay, Emerald Ridge, Mount Rainier. Here it shows the EHZ seismogram. No image. That means they've taken down the seismogram. They don't want to show us a seismogram. Let's click over here on the right-hand side. Okay, we have three other seismograms to look at. These three that do not have a star on them should be active seismograms. So let's go over here to HHE. We should be able to see Emerald Ridge HHE. See whatever it shows us. I'm trying to show you how to read seismograms. Here we're still seeing VHF waves. Very low frequency waves here, caused by magma entering the volcano. Again, we're still seeing that 3.0 earthquake here. Right here, look at these VLF waves. These are very active waves, meaning a lot of magma coming into the magma chamber under pressure. The magma is high in pressure. Coming into the volcano, it fractured the rock here, causing that earthquake. Down here we see some other just tremors. But here is where the most of the activity is here. A lot of magma coming into this volcano. Let's check another seismogram here. Let's go over here to HHN. HHN is the primary seismogram we want to look at when we're looking at VLF waves. Very low frequency waves. Look at this. Again, last night, after 5 p.m., between 5 p.m. and even 8:30, there was a lot of magma activity coming into the volcano. You see a lot of activity here. Down here, we still see a lot of activity, and we're still seeing the 3.0 earthquake. USGS lied to us. Yes, I can guarantee you that there is a lot of tremor going on. There is a lot of tremors going on. However, we're also seeing this earthquake, and it's a lot stronger than a 2.0, or even a tremor 1.0, 1.9. This, folks, is probably a 1.2 earthquake here. I'm not saying earthquake, 1.2 tremor here. Right here, we may have a 1.0 tremor here. That's all. Again, this is Emerald Ridge. Emerald Ridge. Let's go over and show you another seismogram here. I want to go down here to RCS. This is Camp Sherman. Mount Rainier, Camp Sherman. There are many seismographs around Mount Rainier, just like they are around every volcano. This is Camp Sherman. Camp Sherman, we're seeing a lot of other signals going up here. Yes, we're seeing tremors here. We're also seeing earthquakes. On the blue line here, this is a 2.0 earthquake. This here is a 2.8 earthquake here. Right here. This is a magma churn signal. It's a sideways rectangle here. These magma churn signals are 23 to 24 lines high, typically. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9 lines high. This is just less than 50% of real world. The seismograph has been turned down to just less than 50% of real world. Yes, we are seeing tremors. Yes, we are seeing earthquakes here. For example, this is another 2.0. This appears to be another 1.5, 1.7 tremor. 2.0 earthquake here. Here's a 2.8, 2.9 quake here. It's just a vertical line here with a dot in the middle of it. Okay? Down here to the right. This is after 11 a.m. here. This is about 11:10 a.m. here. Okay? This is a 2.8, 2.9 earthquake. You can see that we have some tremors before the main event. Okay? After that, we have also tremors here. Okay? This is definitely a 2.8, 2.9 earthquake here. Off to the right-hand side of that magma churn signal, these are steam signals here. These are all steam signals. Mount Rainier is steaming as well. And yes, we've seen white steam and we've seen gray steam coming from Mount Rainier. Okay? Down here we have another magma churn signal. This magma churn signal should be the same height as the other. But this magma churn signal has been cut off because it will be on the next day's seismograph. So we come back over here to current. See where it says current here? It says view current here. Let's look at current. It's not showing that magma churn signal, is it? But we are seeing tremors, and we're seeing an earthquake here, and we're seeing an earthquake here. We're seeing tremors, and we're seeing minor earthquakes here. Mount Rainier is moving. Mount Rainier is moving. Do you think we're going to see this activity on tomorrow's seismogram, which should be the same as we're seeing now? I doubt it. This is all going to change on the seismogram that we're going to see tomorrow. Okay? It's going to totally change. Now we're looking at Camp Sherman here. RCS. Let's click on it here. Right next to it is RCM, Camp Muir. It's got a star on it. The star means the seismogram is not supposed to be showing. Well, guess what? This is current. We're seeing 3 earthquakes here already. Are we going to see these later tomorrow? I doubt it. I highly doubt it. I've worked with these before. What we see now, we're not going to see tomorrow. So let's go to today's seismogram here. Okay, this is today's seismogram. It started yesterday at 5 p.m. here. Okay, look at this. We're seeing a bunch of tremors here, aren't we? We're seeing a bunch of tremors. This is an earthquake here. This is a 2.7, 2.8 earthquake here. These are tremors right here. Down here. This is just after 4:20 a.m. this morning on this red line. 4:20 a.m. this morning, this appears to be a 2.8, 2.9 earthquake. Not quite a 3, but a 2.8, 2.9 earthquake. Yes, we're seeing tremors all over this seismogram. Again, this is over on the southern side of Mount Rainier, Camp Muir. Okay? Right here. Right here. This is a 3.0 earthquake. It's on the black line here. This is 7:13 a.m. here. A 3.0 earthquake here at Mount Rainier. Look here. This appears to be a 2.5, 2.7 earthquake here. This is also here a 2.5, 2.7 earthquake here. All these are tremors here. All this to the left are tremors. Over here to the right, this is a tremor. This appears to be a 1.7, 1.8 tremor. 1.7, 1.8 tremor here. Okay? So yes, we did have at least 1 to 2 3.0 earthquakes here today at Camp Muir on Mount Rainier. Okay? I'm trying to teach you how to find these seismograms. This is on the Pacific Northwest Seismic Network. The Pacific Northwest Seismic Network. Now, we want to get out of this. We want to look at another volcano. In this case, we want to look at Mount St. Helens. We want to look at Mount St. Helens. So we come up here and search for station again. In this case, we want to look for SEP, September lobe. SEP. We click down here on the larger letters, SEP, September lobe. Then we come over here to view seismogram. We click on that. So this is September lobe from the Pacific Northwest Seismic Network. Now you're not going to find this on the USGS site, meaning the volcano or the Lassen Volcanic Center. Yes, you can scroll up and finally find Mount St. Helens and Mount Rainier, but guess what? You're not going to see the same thing. September lobe is not on the USGS site. Lassen Volcanic Center is the USGS site. So here we're seeing the current seismogram from September lobe. It's been doctored. See the perpendicular lines here? This shouldn't be. This shouldn't happen. Here it appears to be here at 5:30 a.m. today. They figured it out and they stopped the slant. But it remains to see whether it continues though. It could continue. So let's go back here and look at the previous seismogram to today. This is yesterday's. This is tomorrow's seismogram. Let's look at today's seismogram here at September lobe. September lobe is usually the most accurate seismogram we can find here at Mount St. Helens. This is the main seismogram page at September low. Here we're seeing tremors, quite a few tremors. See this solid horizontal lines here? This is what the seismogram should look like. It should never have zigzag lines. If it has zigzag lines, they're playing with the seismogram. Okay? Oh, and here's Ras says, Ron, are they toning down the seismograph sensitivity again on that one? Yes. They have turned down the sensitivity. They have turned down the sensitivity of the seismograph. That's why when I show you that magma churn signal, the height of the magma churn signal is going to tell us how far they've turned down the seismograph. Okay? This one here is September lobe. It's one of the most accurate seismograms we can find here at Mount St. Helens. Over here, on this black line, the black line here is 9 a.m. or 8 a.m. here. We come over here to the right. See this earthquake here? This is Mount St. Helens. We have a dot in the middle of it. This means it's an earthquake. This looks to me like a 3.3 earthquake. A 3.3 earthquake here at Mount St. Helens. Are they going to show it to us on the USGS map? No, they're not. It does not exist on the USGS map for kicks and giggles. Let's go over here to Mount St. Helens right here. This is what they're showing us here at Mount St. Helens. They're showing us a 1.7 tremor here at Mount St. Helens. Why? Why are they just showing us this? They're saying this tremor here, this 1.7 tremor, happened 1.7 kilometers deep, nearly 1 mile deep inside Mount St. Helens. Let's go back over here to this seismogram here. The PNSN seismogram, the Pacific Northwest Seismic Network. This is a 3.3, maybe even close to a 3.5 earthquake at September lobe at Mount St. Helens. Okay? Now, let's go over here to the VLF waves. Okay, the seismogram here. BDF-01. We click on BDF-01 and we're going to see the VLF waves here caused by magma coming into Mount St. Helens. Look here. Last night, 5 p.m., we see very almost straight VLF waves here, meaning there's not much magma coming into the magma chamber here at Mount St. Helens. However, at about 1 a.m. this morning, it turned around. Just before 1 a.m., you see some of this magma coming into the magma chamber gets to look more violent. Down here at 0200, 2 a.m., here you're seeing very violent magma waves here, VLF waves here. This indicates a lot of magma coming into the magma chamber here, under pressure. Under pressure coming into the magma chamber here. Okay, it started here just about 1 a.m. this morning. It continued until just before 6 a.m. here. Interesting, huh? Let's go back to the other seismogram. Look here. Look at this. This happened after approximately 9:13 a.m. this morning. 9:13. Let's go back to the other seismogram here. 9:13. Guess what? Look here. This is 9 a.m. here. We come across here and we don't see much of anything happening. How's that possible? In order for a 3.3, 3.5 earthquake to have happened, we have to have a lot of magma. That didn't happen, did it? That means they doctored this seismogram. They doctored the seismogram. In order for that 3.3, 3.5 earthquake even, we would have to have VLF waves just like this down here after 9 a.m. We're not seeing that. We are not seeing that. That means they're playing games with us. They're playing games. Because this is at least a 3.3, 3.5 earthquake here at Mount St. Helens today. Okay? Do you see what I'm talking about here? Do you see what I'm talking about? This is how you look at the seismograms. You can tell what's going on. I've been reading seismograms for years now. You can't start reading seismograms until you've had some experience. After you get a little bit of experience, you can see what's going on. Ray Spur is asking about the image of the magma chamber under Rainier. We showed that to you just about 15 minutes ago. We showed you all, well, not everything, but we showed you quite a bit of information about what's going on the seismograms at Mount Rainier just about 15 minutes ago. Okay? Mount Rainier and Mount St. Helens are getting ready. They're in the beginning to the middle stages of a possible volcanic eruption at either one or both of these volcanoes. Sometimes we see a lot of activity at St. Helens and not as much at Mount Rainier, but sometimes we see a lot of activity at both. And yes, we've seen that a lot. We've seen that a lot. Monir's Ras says he started learning to read oscilloscopes when he was about 6 years old. So did I. So did I. But this is what's going on at Mount St. Helens today. A 3.3, 3.5 earthquake this morning. About 9:13 a.m. this morning. Okay? Kicks and giggles. One more volcano. One more volcano. I want to show you what's going on at Mount Hood. Okay? So in this case, I want to go over to Palmer Lift. P-A-L-M. Palm. Okay? I come over here to the capital letters. I click on that. Then I come over here to the left and say where it says View Seismogram and click on that. NCWQ Worldwide News and Disasters Explorer is putting her grandbaby to bed. Thank you for everything, Becky. We appreciate you. Becky's having some issues with her car. If anyone can possibly help her financially, you can go to her PayPal and send her a financial donation, help her with her car. Otherwise, she's telling us that she may have to hawk her computer, which means she won't be able to come on the air and do any kind of earthquake forecast or show what's going on from her site. You're only going to get us here at Emergency Management Associates. Okay? Sobak says, so how do people find it on a map? I'll show you. This is Mount St. Helens. They're not showing the earthquake that I just showed you. They're just showing us a 1.7 tremor here at Mount St. Helens. And yet, there was a 3.3, 3.5 earthquake here at Mount St. Helens this morning. USGS is not going to show us what's going on the map. They never will, ever. They will not show us what's going on until they are forced to show it. Now I'm going down here where you see my cursor. This is Mount Hood. Let's go over here to Mount Hood. This is Palmer Lift on the south side of Mount Hood. This is the current seismograph. Right here on this blue line, this is 5:30 this afternoon, Pacific time. You see this? You see this horizontal line? It's thick. When you see the horizontal line, sometimes the horizontal lines get thinner. This is called magma pulse signals. Sometimes it starts off with thinner lines and gets thicker, and then it gets thinner again. Again, magma pulse signals. In this case, it gets thinner here, and then all of a sudden we have a thicker line, and we have earthquakes. Sometimes we just get tremors, but in this case, we have earthquakes here at Mount Hood. This is halfway up Mount Hood, halfway between the summit and the foothills of Mount Hood. Palmer Lift. This is the top of the ski resort at Mount Hood on the south side. Look at this. Look at this lower line here. We may have had a 3.0 earthquake here this evening at Mount Hood. Are they going to show us that tomorrow? They might or they might not. They might completely omit this information here when we see this scene tomorrow. And I'm going to show this to you tomorrow because I'm very interested to see whether they're going to be honest with us. Sometimes they omit the information completely. Let's go back to today's seismograph here. We click on previous. Again, the top of Palmer Lift. This is halfway up the volcano on the south side of Mount Hood. Look at this. This is starting off at 8:15 on the red line here on the left. It's hardly showing us anything here. These are tremors. All this is tremor activity here. Okay? Down here, we're getting the rat-a-tat-tat signal here. The rat-a-tat-tat signal is they're drilling into the upper magma chambers of Mount Hood to obtain steam to power turbines. That's what we're seeing here is a rat-a-tat-tat signal. Okay? We shouldn't be seeing this. They have altered the seismogram for us to see this. Down here, okay? Down here is 1500. This is 3 p.m. today, Pacific time. We come down here, and over here on the left-hand side would be 1530, 3:30 here on the blue line, and over here, now we're about 3:10, well, maybe even 3:08 p.m. this afternoon. This is a 2.2, 2.3 earthquake here. Right here, this is a 2.8, 2.9 earthquake here. Okay? This afternoon. Right here we have tremors here. Now, we can go up here to the top here. This is Palmer Lift. We can click on this. We go down here to Timberline. This is the southern part on the lower side of Mount Hood. Timberline. It looks like Richard is going to sleep. Have a good night, Richard. We love you, brother. Take care. We'll talk to you tomorrow. Again, Timberline, guys, a different seismogram. Okay? Different seismograph. Totally. Look at this. 2000 hours last night. Over here. 8 p.m. on the black line. We go over here. This is about 11 minutes after 8 p.m. last night. This is a 3.0 earthquake. This is at least a 3.0, 3.3 earthquake here. Prior to that, we have a 2.0 earthquake. Building up of tremors prior to the main event. The primary wave right here. This is all secondary wave out here. The secondary wave lasts a minute and a half, which means to me this earthquake may have been as much as a 3.5. This earthquake here must have been at least a 3.5 earthquake. To have a 1.5 minute secondary wave means this quake was a 3.5 quake. This earthquake just prior to that looks to be a 2.8, 2.9 quake. It's got seismic energy, tremors building up to the primary wave here. And out here to the right, we have a secondary wave here. The secondary wave lasts about 45 seconds. Okay? We continue down here. Okay? 2200 hours, 10 p.m. last night. 2300 hours. We see nothing but tremors here. We see nothing but tremors all the way down here to 5:30 p.m., 5:30 a.m. this morning. 5 o'clock. 5:15 on the red line. They have the lines kind of mixed up here. The black line here is 5 a.m. 5:15, we have these tremors here. More tremors here. This is 6:23 a.m. here. Okay? This is about 6:10 a.m. here. Okay? We come down here to 11:09, 11:10 a.m. here this morning. Or no, I'm sorry. This would be 11:09, 11:10 a.m. this morning. This appears to be a 2.5 magnitude earthquake here and a 2.4 right here. The secondary wave here lasts almost a minute and a half to 2 minutes, which means this earthquake may have been as much as maybe a 3.0 earthquake. They're not showing it here. That means they turned down the seismograph. They've turned down the seismograph. They're not showing us exactly what's going on. That's the other way we can see what's happening, is we look at the secondary wave. If there's a long secondary wave and a shorter primary wave, that means they turn down the seismograph. Okay? They turned it down. Over here, on the black line, this would be, over here on the left it says 1 p.m., 1300 hours. Over here on the right, this would probably be 1:13 p.m. here. Again, this was turned down. This appears to be at least a 2.9 earthquake. It could have been as much as a 3.1, 3.2 earthquake, because the secondary wave here lasts 45 seconds. 2.9, 3.0 earthquake right here. We had plenty of tremors leading up to the primary event right here, the primary wave here. Okay, on this blue line here, this would be 3:30 p.m. this afternoon over here on the left. Over here, this would be 3:40 p.m. here. About 3:40 p.m. here. This would be probably a 2.3, 2.2, 2.3 earthquake here. This is Mount Hood. This is Mount Hood. Now we can come over here and we can go up here to the north side of Mount Hood, Yoakum Ridge. Yoakum Ridge is about the same elevation as Mount Hood. Look here. We're not seeing hardly anything here. But over here on the north side of Mount Hood, we're seeing a 3.3, 3.4 earthquake right here. Okay? This happened about 3:40 p.m. this afternoon. And this is a 2.8 earthquake here. 2.7, 2.8 earthquake here with a 3.3, 3.5 earthquake here. Yoakum Ridge at Mount Hood. Okay? Now I'm looking for another seismogram here. It's called Trade Dollar. No, I'm sorry, not Trade Dollar. This is Tom, Dick, and Harry. Tom, Dick, and Harry here at Mount Hood. Guess what? They have taken this seismograph down. They've taken the seismograph down. Guess what? There are other stations reporting. I clicked over here on the EHZ symbol where it had the star here. It means they've taken this channel off. This is the multi-channel seismograph. Let's look here. 1, 2, 3, 4, 5, 6, 7 channels. 7 channel seismograph. Let's go over here and look at E&E. Well, lo and behold, we have a seismogram, don't we? This shows tremors yesterday afternoon. 5 p.m. at the top. Just tremors down here. We come down here to late this morning. All of a sudden we have some earthquakes. Tremors and earthquakes here at Tom, Dick, and Harry. Interesting. Right here, we have a 1.5, 1.6 tremor here. The same thing here, the same thing here, here. Here's a 1.2, 1.3. This is a 2.1, 2.2 earthquake here. Here's a 2.1 earthquake here. This appears to be a steam signal. The signal does not have a dot in the middle of it, which means this is a steam signal. It's steaming there. This is an earthquake here, a 3.0 earthquake here at Mount Hood at Tom, Dick, and Harry. Okay? So we can pull up other seismograms sometimes if it's a multi-channel seismograph. Okay? Let's look at another one. This is ENZ. Over here, the ENZ does not have a star by it. That means we should see a seismogram here. And sure enough, there it is. And again, we're still seeing this 3.0, and this looks like it might even be larger than that. This appears to be a 3.3, 3.5 earthquake here on this particular seismogram. But it was at least a 3.0 earthquake here at Mount Hood. So Mount Hood is also experiencing small earthquakes. Small earthquakes here at Mount Hood. Does anyone have any questions for me as to what we've just been seeing? I've shown you how to look up seismograms at the Pacific Northwest Seismic Network, looking at the different volcanoes. And no, the Pacific Northwest Seismic Network, we cannot see Mount Shasta and Mount Hood. We only can see that over on the Lassen Volcanic Observatory right here. And again, USGS that runs this seismic network here is not showing us everything. They've taken the seismographs down. They're not showing much of anything, including Medicine Lake Volcano here. They're not showing us anything there at all. They're playing games. Does anyone have any questions for me? Now, I didn't mean to go on so long as we have. It's now been over 2 hours here. I know we've talked a lot here. Monier's Ras says, no questions, it's more seething anger at the people that are doing it. Suppressing information clearly. Okay? I told you before they're suppressing information, now you can see it. Now you can see it. You can actually see what they're not showing. They are absolutely lying about everything. I've shown you that on the main USGS map. They're not showing much of anything because they don't think they have to. They don't think they have to show anything. That's how they operate. That is just how they operate. It's stupid, guys. It really is. It's really stupid. When I first started looking at what they're telling us or what they're not showing us, I became angry. Now I began accepting it because I know exactly what they're doing. I know exactly what they're doing. There's no doubt in my mind of what they're doing here. They do not want us to see the information. They don't want us to see the information at all. And they're not going to show it to us, period. It's sad. It's just plain sad. Okay, guys, if you don't have any questions, I'm going to tell you something here. There's a couple things. We have my friend Laura Marie here. She and her dear husband sent Carol and I a card. And they also sent us a gift certificate. They sent us a gift certificate. Yes, you all can do the same thing. Okay? Within 10 minutes after we get off this program, just below this video here, you're going to see a program description. Just below this video, in 10 minutes after this program ends, we're going to fill out that program description. In the top of that program description, you're going to see how you can join as a member of the program. It'll have a link there to join as a member of the Emergency Management Associates Network. Okay, you'll see that link. After that, you're going to see the rest of the program description. You're going to see our email. You're going to see 2 PayPal addresses. You can send us donations to those PayPal addresses. Please do it. We still have bills to pay, and the bandwidth to put on this program costs a lot of money. Right now I'm paying $175 a month for bandwidth, for 1 gig of bandwidth. And you can see what it's doing. Even from my tablet here, we're seeing very perfect broadcast, or near perfect broadcast. Go over to our PayPal links. We have a Hotmail link, and we also have an Emergency Management Associates link. You can use either one of those links to go to our PayPal and send us a donation. We greatly appreciate it. You can also see our mail address to our post box. It's at 104 North Green Street. 104 North Green Street, Box 105 in Morganton, here where I live, Morganton, North Carolina, MORGANTON, North Carolina. The zip code is 28655. You can send us donations through the mail. We've done that a lot. And as you can see, our dear friend Laura Marie and her husband John sent us a card and also a donation. We greatly appreciate it. On this card she sent us, these are pictures from Hawaii. Pictures from Hawaii. Beautiful pictures. Okay? They just returned this past week from the Big Island. They went over the Big Island to Pahala, where her grandson graduated from high school. You can see pictures here. This picture right here with the sign says Hilo, go straight, and to Kilauea volcano right here. Okay? Hilo straight down the highway and over to Kilauea there. Right here, look at that. Look how pretty this is. Okay? This appears like they're going down to either Pahala or over to Hilo. It's very beautiful, isn't it? Right here is Pahala Elementary School. Pahala Elementary School right there. Look at that. Isn't that cool? And then right here, look at that beautiful rainbow here. Absolutely stunning. Laura Marie and John, thank you so much for that card. This is such a beautiful card. We appreciate this, Laura. God bless you and John for sending us the donation and for sending us this beautiful card and the sunset here on the Big Island. It's beautiful. Thank you so much, guys. We love and appreciate you so much. Now, Greg and Donna also sent us a donation via PayPal. I want to thank you both for that. Greg and Donna have been sending us donations to PayPal for quite some time. We appreciate so much. Please, folks, continue to use PayPal. Continue to send us donations through the mail as well. We greatly appreciate that. God bless you for that. It means a lot. Now, yesterday afternoon when I was teaching my Sunday school class, I opened my scriptures. Frequently, I open my scriptures right to a scripture that I need to see. In this case, yesterday afternoon, I opened it to the first epistle of John, here in chapter 1. I want to start with verse 3. Here, John is talking to the saints, okay? The saints gain fellowship with God by obedience. We must confess our sins and gain forgiveness. Here in verse 3, that which we have seen and heard declare we unto you, that ye also have fellowship with us. And truly our fellowship is with the Father and with His Son Jesus Christ. Yes, it is. Each one of us can gain fellowship with God and Jesus Christ through the scriptures. Isn't that cool? Then we come down to verse 7. And I love verse 7 and 8 and also 9 here. Let me make sure I have the right number of verses here. And 9 and 10. So we're going to read you verses 7, 8, 9, and 10. Verse 7. But if we walk in the light, as He is in the light, we have fellowship one with another. And the blood of Jesus Christ, His Son, cleanses us from all sin. If we say that we have no sin, we deceive ourselves, and the truth is not in us. If we confess our sins, He is faithful and just to forgive us our sins, and to cleanse us from all unrighteousness. Verse 10. If we say that we have not sinned, we make Him a liar, and His word is not in us. If we say that we have not sinned, we are lying to God. We are lying to God. Remember that. Don't lie to God. God and Jesus Christ do not like to be lied to. I opened this scripture yesterday afternoon, just before I got off the air. I should have read it then. But I definitely wanted to show it to you or share it with you tonight. I love the scriptures, brothers and sisters. I indeed love the scriptures. And I love sharing the scriptures with you. Brothers and sisters, as I have said before, the scriptures. Reading the scriptures gets us closer to God. And not just that. It prepares us for eternal life with our Heavenly Father in Jesus Christ. If you really want to know what's in the scriptures, read it. And you're going to find that you draw closer to Jesus Christ. Yes, Linda, I'm not going to get ink on my shirt. I appreciate that. I do appreciate that. But folks, please read the scriptures. That's why I share them with you every night. I want to show you what's in the scriptures, because you're going to find that the scriptures are just a small trip into eternity. And through the scriptures we can find eternal life, which gift is the greatest of all gifts of God. please read the scriptures. Share them with your family. That's why I share the scriptures with you. Because the scriptures are beautiful. There is no substitute for time with the Word of God. Generosity's just said that. I just repeated it. There's no substitute for being in the scriptures. There's no substitute at all. At all. Brothers and sisters, I love you. I love you. I appreciate all of you. I appreciate all of you. I want to share as much as I possibly can. I run out of time. I literally run out of time. May God bless you. May God bless you. You can send me an email if you have questions or thoughts. And if you want me to share a thought with all of the rest of you, please tell me I can share it, and I will. Just like I showed you this card from Laura and John, who were kind enough to send Carol and I these beautiful pictures. Linda Covington says her Bible is large print. Mine is medium-sized print. Okay? I'll show you. Mine is medium-sized print. I can no longer read tiny print like the phone book. This is medium print. Okay? Yes, I've got good eyes, but I now wear glasses so I can see even better. Folks, I love each and every one of you. I appreciate your support of our program. I appreciate your love. I appreciate you being here on our program. Please share this program with everybody you come in contact with. Share this program with your family, your extended family. Share it with your neighbors and friends. Share it with your social media contacts and even the people you work with. Let's grow this channel. Don't do it for me, but do it for yourselves. The more we grow this channel, the more people we bring in here, the greater likelihood is we get this emergency messages out. We get to show everyone what's going on around the world. We get to save lives. On Fridays, we talk about emergency preparedness so we can save lives. Please share this program with everybody. And guys, 25% of the people that watch this program are not members. They're not even subscribers. Subscribe to this program, guys. It's critical. Subscribe to this program. That way you'll get notified when we come on the air. Subscribe to this program. When you subscribe to the program, folks, click on that little bell icon. It's a tiny bell icon right next to the subscribe button. Click on that and another drop-down menu will appear of 3 items. Click on the word ALL. If you're not being notified when we come on the air, please resubscribe, unsubscribe, resubscribe, and immediately click on that little bell icon and click on all, AL. That way you'll get notified when we come on the air, at least for a while. Don Patolka, who's one of my best friends on this program, he's one of my mods, one of my best friends. He and Rob have to resubscribe all the time, so they get notified when we come on there. And yes, it's a sad day because YouTube decides that they're going to suppress who they're going to allow to see our program. But that's how to do it. Please subscribe to this program so you get notified when we come on the air, so you get notified about what we talk about. We talk about emergencies and disasters, anything from floods and rain to fire, wildfire, house fires, building explosions, shootings, earthquakes, hurricanes, tornadoes, any kind of emergency you can think of, we talk about here. We talk about here. Yes, Heather, you missed the devotional. It's the first epistle of John, starting off with verse 7 through verse 10. It's beautiful. Go back and listen to it, Heather. It's beautiful. And also, It's poison for each one of us. Brothers and sisters, subscriptions don't cost anything. Membership costs $1.99 and goes up to $2.99 and $3.99. Even that is dirt cheap. Please subscribe to this program and get a membership to this program. You will get it and you'll be happy you did and happy you support this channel. Now, brothers and sisters, I love you. I love each and every one of you. Please, though, please share this program with everybody. Please give your families, your spouses, and your children hugs. Please give them hugs and tell them that you love them. Tell your kids and your grandkids and your spouse that you love them. It's worth it. It's worth it for everybody. Our families deserve to know that we love them. And don't just make it a voice thing. Show them you love them. Show them you love them. Brothers and sisters, I love you very much. That's why I come on the air. That's why I share things like I do. May God bless you. May God be with you this night, this day, and always. God be with you until we meet again. Know that I love you. My wife and I love you very much. She's the one that keeps me going. My dear wife loves all of you. And sometimes you see her in the chat. Other times she's there watching and listening. She loves you as well. God be with you until we meet again. We will see you tomorrow, same time, same station. If anything else happens tonight, we'll be coming back on the air as soon as the information becomes available. Until then, guys, have a great night. Much love. We love you very much. See you soon. God bless. Bye-bye.